Okay, class. Hello, everyone. All right. So today, actually, I think already give you the exercise for the chapter one that we will be discussing for today. All right. So I just start the class. All right. So this is actually from chapter one, and I take this one from the trial exam. Okay, this year. Okay, from another state. Okay, so let's see the first thing. So actually, during like your form four, okay, chapter one, okay. So this is basically from your textbook. So maybe let's say if you have a revision book or you have your notes, right? So maybe you can like take the important part. Means whenever the question asking you about something, then oh, so this part is usually being asked in the question. So for this part, we only chapter one and chapter two we combine the objective, but then for the essay, all right, for the structure and also essay also, I will be discussing after we finish the paper one and paper two for chapter one and chapter two. Okay, so we will do at the same time. All right, so the physical quantities. So basically, when they come for the physical quantities, right? Some of the question, right? They will ask you, right? What actually the physical quantities get being measured by the thermometer, right? What is the physical quantities that be measured by by thermometer? Okay, so some of you got confused, right? Some of you will put the unit, right? So they put Kelvin because that is the base quantity, right? So this the unit is Kelvin. So you need to know that actually when they ask you for the physical quantity, it means like what does the uh the measuring instrument can measure. So example, if they put it there thermometer, so it's actually measure the temperature, right? So this temperature we call it as the physical quantities. Okay, and the symbol for the temperature is T. Okay, and if they ask for the SI unit, for the SI unit, then you said Kelvin. Okay, because I noticed some of you when they ask you, let's say what is the physical quantity? Let's say they ask you, they actually is a velocity as the answer, right? Okay, but you put it ms negative 1. Okay, that if they ask you for the SI unit. Okay, so this is SI unit. If they ask you for the physical quantities, it mean like what does it measure? It measure what? It measure temperature. What does it measure? It measure length. It measure time. Okay, so that is a physical quantity. Alright, so we've and then other of it, I just go through, right? So actually, this one you already learn, okay, in during form one, okay, for the basic quantities. Okay, so it says the physical quantities must have a magnitude. Magnitude is actually the number, the unit, and of course the physical quantity. What does it measure, right? And can you see the unit in centimeters? So this is on your ruler, right? So centimeter is example of metric unit. Okay, the metric unit is centimeter, but inch is actually the imperial unit, right? In the world, okay, in the worldwide, or usually we use a basic quantities as such as a meter, centimeter. We don't use inch, right? Okay, so nowadays we are more familiar with the matrix unit, so the imperial units are seldom, okay, or you seldom use. Okay, then other example like the gallons, miles, okay, feet, yards, right? So they don't use this one very frequently. Okay, so this is actually the base quantity and the derived quantity. So what is the difference? So base quantity is that you cannot derive it anymore. Okay, that is the base. Okay, let's see for length, meter, right? That is the base. You cannot derive the length. Okay, so it's a cannot be derived by from another physical quantity. That is the basic. Okay, so they got like seven of it. Okay, five you already learned during form one. Okay, length, mass, time, okay, thermometer, and electric current. This one you already learned during form one. And when you from four, you just add two more. That is a luminous intensity. Okay, that the unit is a candela. The symbol is CD. So amount of substance, right? And the unit is mole, okay, and also the symbol is mole. Okay, this one usually you see it in chemistry. Okay, so there are seven basic units. So this is the base quantity. You cannot derive it anymore. Alright, so length, the symbol, you have to know the mass, the time, okay, the thermometer, thermodynamic thermometer, T, capital letter T, okay, I, okay, this is the symbol for luminous intensity, IV, and this is the amount of substance. Okay, that is the base quantity. That is a basic. You cannot derive anymore. Only got seven. So just remember these seven. Okay, but then when let's say for the derived quantity, so from the derived quantity is actually you use a multiplication, okay, or maybe a division, okay, or you can divide the base quantity to form another SI unit. Okay, so example for volume, right? So the volume we already know, length, okay, times with the height, right, and times with the length, height, and then another one is width, right? So you got the volume. Okay, so we use the multiplication, right? Okay, we use the multiplication. So we use a multiplication in the using the base quantity, right? So let's say for the length is m, for the volume is m times m times m, right? The unit meter times meter times meter, you got meter cube. Okay, so we use a base unit, okay, and we multiply or we divide it, you got another, alright, another physical quantity, okay, or derived quantities. Okay, so this is the example. So for velocity, there is actually displacement divided by time, right? So that one we use a division. Okay, so velocity is displacement divided by time. So displacement is meter, time in second. So we got ms negative 1. So we use a division, but we use a base unit because displacement meter is a base quantity, right? Time is in second is a base quantity. So both of it, we use the base quantity. Okay, we use the base quantity, we multiply or we divide, or we can use both also, multiply and also divide. Okay, you can get another quantity. That is derived quantity. Okay, so I just go faster for this one. Okay, so scalar and vector. Okay, scalar must have a magnitude, vector must have a magnitude and also direction. Alright, must have a magnitude and also direction. Example, velocity. Okay, so for velocity, remember if they move at the to the right, okay, usually we put it as a positive symbol. If they move it to the left, we put it as a negative. Okay, this part is actually important when you calculate, let's say, for the momentum, right? Remember the elastic collision or inelastic collision. Okay, some of the object will move same direction, but some will be moved at the opposite direction. So the positive and the negative part, you have to put, okay, in the equations. Okay, so you need to know whether it move in what direction. So we just assume positive is positive is to the right, negative is to the left. Okay, but teacher, if let's say I want to change, is okay, doesn't matter. Okay, but usually we put the right is positive, left is a negative. Okay, so this is scalar that only have magnitude, vector has a magnitude and direction. This is the example. Okay, right, this is the graph. Okay, I will just skip this one, okay, because we already learned for this one actually for power paper 3. Okay, so let's discuss for the question. So the first question, right, they ask you which pair is correct. Okay, so the quantity and the type of quantity. So weight is actually mg. Okay, and you know what does it mean by weight? Sometimes they ask you what does it mean by weight. Okay, weight is actually the gravitational force acting on the object. This is the meaning of weight. Okay, can we use a formula, teacher? Mass multiply with the gravitational acceleration. No, cannot. Not all the meaning, okay, not all the meaning of terms you can use the formula. Okay, not all meaning of the can use. So this one is actually is come from the formula also, but we don't put like mass multiplied by the gravitational force. Okay, because this is actually we know the gravitational force that acting on the object. Okay, so mass is the of course the object. So W is equals to mg, and remember the unit is Newton. Okay, so weight is a vector. Is it correct? Yes, because weight, okay, whenever you draw the direction of weight, okay, it's always go down. It's always same as the direction of the gravity. Okay, so it will go down. So means it's a vector because it have a directions. Okay, so number one, the answer is A. Okay, so others, distance is not a vector because it only have a magnitude, but displacement is a vector. So you need to know, okay, they have a pair, right? If you say distance, then I know this is the scalar. Okay, I just do the correction here. Displacement is a vector. Okay, if example, if I say distance, the distance between A and B is 5 meter. Okay, so mean they got only magnitude, no direction, right? So that is a scalar. But if I said the displacement, okay, between A and B is 5 meter to the north. So that one is displacement. Okay, the magnitude is same, okay, but one got direction, one no direction. But the name is different. Distance, you don't put the direction there. Displacement, yes, you put the direction. Okay, then the velocity. Velocity is a vector, not a scalar. Okay, then for the scalar, for this is called as a speed. Okay, example. The speed of car is 50 meter per second. Okay, the speed of car is a 50 meter per second. So is there any direction? No. Then we call it speed because no direction. But if I say the velocity of car is 50 meter per second to the west, so means is the velocity. Sorry, the velocity. We don't call it speed. Sorry. The velocity of the car is 50 meter per second to the west. So you cannot call the speed. You cannot say the speed is 50 meter per second to the west. We know because it's not speed. Speed is a scalar. So you need to call it velocity. It's the same thing, but only got different in the direction only. Okay, then the acceleration, this one is a vector. Okay, it's not a scalar because you have a negative, right? A negative, -2, that is a deceleration. Okay. So for number 2, this one is easy. Increasing linearly, okay? Since we just finished paper 3, so of course you know this is increasing linearly. This is directly proportional. This is inversely proportional. This one is decreasing linearly. Okay? Decreasing linearly. Okay, decreasing linearly. Okay, maybe you can just put notes there. Okay, increasing linearly, directly proportional, inversely proportional. Okay, next part. Which physical quantity is a scalar quantity? So scalar means they don't have the magnitude, right? They don't have a magnitude. They don't have the direction. They have a magnitude but not direction. So the answer, of course, mass. Mass don't have a direction. Okay, you need to know the difference between the mass and the weight. If they ask you the meaning of mass, okay, so meaning of mass is quantity of matter. Okay, if they ask you for the weight, it's a gravitational force that acting on the object. Or velocity is the rate of change of displacement, not speed. Okay, rate of change of displacement. Rate of change of, correct lah, displacement. If they say rate of change of distance, that one is speed. So don't confuse. Okay, speed, distance, velocity, displacement. Okay, so acceleration, rate of change of velocity. Okay, for number 2, table 1 shows a list of unit of derived quantity. Okay, which of the following pair is correct? So to answer this question, the first thing you have to know the formula. Okay, so we know that momentum is P is equals to mv. The pressure is P is equals to F over A. The work is W is equals to Fs. The force is Mf is equals to Ma. Okay, so now we try to derive the formula. This is the formula and we have to derive the unit. So M is the mass. So what is the unit for mass? Kg. What is the unit for the velocity? Ms negative 1. Okay, then this one force, right? So force is actually equals to ma. Okay, so mass is kg, acceleration is ms negative 2. Please don't confuse with the acceleration and velocity. Acceleration ms negative 2, v is ms negative 1. Okay, so I put here the unit kg ms negative 2, then divide with area. So area is length times width, right? So mean m square here. So we can cut it off, okay? Then it will become kg m negative 1 as negative 2. Okay, but this one they give you the unit nm negative 3. So this one is wrong. Okay, because the m is actually negative 1. Right? So this one also wrong. Okay, work. Work is Fs. S is the displacement. Okay, so force we already know kg ms negative 2. So displacement is m. So kg m square s negative 2. So if you see kg m square s negative 2, right, this one your m is only 1, correct? So your s is negative 1, but here your s is only, your s is negative 2 here, but this one is s negative 1. Okay, so this one also wrong. Okay, then you see the force lah. I already show okay how to derive the unit for the force. So this is the answer D. Okay, let's see if you have a question. Maybe you can just raise your hand there. Okay, I will see. You can put in the chat, right? Okay, this one is a graph, line graph between two variables. Okay, so it said which statement is true about the graph? Y is inversely proportional. No, this is not the graph for inversely proportional. This is decreasing linearly. Okay, it says the higher the x, the higher the y. No, this one, the higher the x, the lower the y, right? So C, y decreases linearly with x. So the answer is C. Okay, so you have to be the different. Linearly mean is in the straight line. It decreases with the straight line. Okay, so the gradient is decreasing. This one is not. Remember when I said about the gradient, must have a triangle. So in exam also, in paper 1 also, you have to draw a triangle. Okay, but if you see the size of the triangle is the same, right? Okay, so means the gradient is same, not decreasing. Decreasing usually the curve graph. Okay. Okay, which of the following physical quantities is not a base? So we remember 7 of it, right? So this is the candela, right? This is quantity of matter is mass. Okay, the meaning of mass. So the answer is B. Weight is not the base quantity. Weight is a derived, right? By using the formula W is equals to mg. Right? Okay, mass is same as this one. Okay, they're just giving you the name of it, the meaning of the mass. Okay, number 2, which pair of quantity is correct? Scalar got magnitude only. Okay, so of course this one C lah. Right, scalar got magnitude, vector got magnitude and direction. Okay, next one. Which of the following is a unit for the base quantity? Base quantity, this is joule. J is joule means energy. No, that is not base. Base only got the 7 that I asked you to remember. Okay, this is for the temperature. Okay, but that is not the base quantity. Okay, so we use temperature. The base quantity for temperature is Kelvin, right? So this one is wrong. N is a Newton. No, Newton is from the F is equals to MA, right? That is also a derived quantity, not a base. Okay, and this is A. A is actually the ampere come from the current. Okay, so the answer is D, donkey. Okay, for the next question, it asks you say has a positive gradient. Y is inversely proportional to X. Okay, so which graph is correct based on the statement above? Okay, so the first graph, this is increasing but not linearly. Okay, this is increasing but not linearly because it's curved graph, not a straight line graph. And this one, y is inversely proportional to x. But it says here, he has a positive gradient. So if I draw the triangle here, you can see the size of triangle is decreasing, right? So it doesn't have the positive gradient, it will have a negative gradient, right? So B is also wrong, but only this one is correct, but this one is wrong. Okay, let's see for C. Okay, this is the graph when they change here 1 over x. So if they change the graph y against 1 over x, it become the straight line. Okay, actually the graph if y against x is inversely proportional. But when you change it, the x to 1 over x, it become directly proportional. Okay, but now the question said here x. Okay, but if I change the graph here from y to y against x, it will become inversely proportional. So the first thing this one stated, okay, this one is correct. Okay, and it has a positive gradient. Yes, because we draw the gradient is increasing, right? So means the value is increasing. So of course it has a positive because the graph is increasing, so it has a positive gradient. So the answer is C. So whenever you find this one, this type of question, read carefully all the answer given. Okay, you got 1 hour 50 minutes. Okay, answer 40 question. Okay, it's different from the last, the previous previous format that we have 50 question, you have to answer in 1 hour 50 minutes, you got 40. But then of course, when they said 40 question with the same time, the question will be quite hard and also will be long. Okay, it's not the direct question like that. So as you can see here lah, okay, if you say inversely proportional, then you will just straight away put B. Okay, then you have to read it, the x axis what. Okay, please be careful. Okay, so the answer is one C. For this part, it says the diagram 1 shows information about the light bulb displayed in the light shop. Okay, this is the characteristic of the light bulb. Okay, it's color white, power 40 watt, the luminous intensity 7543 candela, and the illuminated surface area 0.88 meter square. So now they're asking you, which of the detail given in diagram 1 is a base quantity? Okay, power is a derived, right? Because it's actually, if you learn, P is equals to VI. Okay, don't be confused with the power for the force. That one is for the motion. Okay, P is equals to W over T. That one is for the motion. Okay, but for the electricity, the power we define it as a V times I. So you need to know the difference between those two. Which part is using in the motion? Okay, which formula used in the electricity? Okay, so this is not the base because it's a derived quantity. Okay, you need to V times V with I. Okay, then another part voltage. Voltage also is not the base quantity. This is actually the work, right? The work done. Okay, to transfer from one point to another point. Okay, so that is not a derived quantity. Sorry, it's not a base quantity. Okay, then the luminous intensity. Yes, this is included in 7 base quantity, right? That I asked you to remember. So the answer is C. Okay, for number 2, okay, this is R against 1 over A. Alright, so remember 1 over A. So if I ask you to draw R against A, what the graph will be? The graph will be inversely proportional. Okay. So now it says R is directly proportional to A. No, it's directly proportional to 1 over A. Okay. Then R is inversely proportional to 1 over A. No, it's directly proportional to 1 over A because it passed through the origin. The unit for the gradient of the graph is kilo ohm mm power of 2. Okay, this one is actually, we learned this one in paper 3. Okay, but then I said even it come out paper 3, paper 1 also can be. We still have to use, right, what we know for paper 3, the Amali. So the gradient, okay, you already know the formula, okay, y2 minus y1, x2 minus x1, right? Okay, this is the value. Teacher, how about the unit? The unit is the y-axis unit. Y-axis unit, you divide it with x-axis unit. So what is your y-axis unit? Kilo ohm. Okay, kilo ohm. Okay. And x2 is mm negative 2. Right? Okay. So the unit is kilo ohm mm negative 2. Then they said the unit for the gradient is k or k ohm mm power of 2. Okay, so let's try. Okay, k ohm divide by 1 over mm negative 2. Okay, because it's divide, right? It's a division. So then this one will become multiply. Okay, this will be on the top. This one will be down. So it should be okay, k ohm power of 2 code if I'm not mistaken. Okay, so let's see the value of the gradient here. Y divide by x. No, yeah, so the answer is C here. Because if you check for D, right, 0.005, okay, it should be 0.005 divided by 5. It should be y divided by x, right? This one is 0, okay, we just ignore. So your y is 5. So 5 divided by 0.005. Okay, so this one is wrong. So answer is B, C. If you are not sure, okay. So the answer is C. Okay, the next part, which quantity? This is the same question as before. So the answer is C. Okay. And this one, which correct with the measuring instrument is being used to measure one physical quantity, meter lux. Okay, so this is actually, if light is a candela, okay, there is a luminous intensity. Okay, so luminous intensity is the base quantity and also scalar. Of course lah, there is no direction, right? So C, okay, for the light. Because they use a meter lux. If they use a ammeter, then it's a current. Okay, if you use an ammeter, then it's a current. Meter lux is actually to measure the luminous intensity. Okay, number 1 here, it says a diagram 1 shows 2 children playing on swings with different length at the playground. It will found that the period of oscillation for each swing is different. This one is like a pendulum. Okay, so which of the following correct statement is correct? So the length of string increase, the period of oscillation decrease. Okay, what does it mean by the period of oscillation? Period of oscillation means the time, okay, the time for one complete oscillation. For one complete oscillation. Okay, so when you increase the length of the pendulum, so you can see it moves slower, right? So mean it takes a long time to make one complete oscillation. So A is wrong. Okay, the length of spring increase, the period of oscillation also increase. Yes, the answer is B. Okay, this one is not directly proportional. Okay, if you want to get the graph directly proportional, you have to find t square, right? When we draw the graph, we put t square. We don't use t. If t, you got a curved graph. Okay, so the answer is B. In order for it to change to a straight line graph, you need to put t square, not just t. Okay, so the answer is B, boy. Okay, which one is a vector? Vector is force. Energy don't have a direction. Mass is a scalar, no direction. Speed is a scalar. If they said velocity, then vector. Okay, number one here, a ruler. Inch example of the imperial unit. Okay, this one we already discussed just now. Okay, imperial unit, inch, gallon, right? Feet, inch, okay, yard. Okay, that one is imperial. We don't use it, okay, commonly. Okay. And which of the following is not a base unit in the SI unit system? It's not a base unit, so of course the answer is centimeter, because length we use a meter, not a centimeter. Centimeter, if you got this one, you need to change it to centi is what? 10 power of negative 2. Okay, so it's not the base unit. Okay, only meter. Okay, number 2. So this one is very easy. One is y is directly proportional to x. So number 2 is A. Okay, this one, which of the following scalar and vector are matched correctly? So this is not scalar, no. Okay, energy, right? Energy. So this is a scalar. Vector, linear speed, no. Work Fs. Work Fs, half-life, frictional force. Half-life, we don't have a direction. Half-life is the one that we learn in radioactivity. The amount of time need for this substance to become half from its original value. Okay, so that one is time, right? So yes, vector, yeah, the friction force. Okay, because the friction force always oppose the direction, okay, of the force applied. So let's say if you drag the box, okay, to the right, then your frictional force will be to the left. So the answer is B. Okay. All right, number 2. So this is actually the decay activity of radio substance. So it says the decay activity of radio substance increases with decay time. Alright, so it's starting from 400, okay, 400, then it decrease until here, okay, cannot intersect with X. Okay, remember for this graph, for the radioactivity, cannot intersect with X. Okay, it says the decay of activity substance increases with the time. I think no. Okay, it become decreasing, right? Because this amount of substance becomes smaller. Okay, the first thing is 400. So let's say if I put let's say 300. Okay, during 400, okay, the decay time is 0, starting because it's not starting yet. Okay, let's say if I say 300, then it's like around 2, 4, 6, 8 days. Okay, 8 days. Okay, if I take 200, then it like become 14 days. Okay, so increases the income value, yeah, so it's actually decrease. Okay, you can just read from the graph. Okay, and then this is the decay activities already directly proportional. No, this is not directly proportional. The decay of radio decreases with time. Decreases linearly, no. Okay, this one when they mention about the decreases linearly, no, it's not linearly. Okay, so the decay substance decrease, yes, with decay time. Okay, 300 if 200, yeah, then the time increasing, you can see the value of the activity become, the time increasing, the value of the activity is decreasing. So it's a decreasing. So don't put linearly. Linearly means they have to be like this. Okay, the graph is curved. This one is the formula. Displacement divided by time. So velocity. Okay, this is the like a maths question. You need to form the equation. So your y is s, okay, and your x is t, and your intersection of y is 10. Okay, the gradient, we use a negative y-intercept, okay, divide by x-intercept. So negative 10 divided by 10. So you got negative 1. So just put m negative. No need to put negative 1 lah. Okay, just put the negative here. So you will get B bond. Okay, just use the equation in the maths. Which of the following base and its symbol of the SI quantity is correct? The answer is mass. Time is second. Electric current is ampere. Temperature is Kelvin. Wait. Wrong. Mass is in kg. Oh, D. I forgot. They didn't see. So mass is kg, not gram, right? Okay, so the temperature is in Kelvin. Okay, which of the following consists only scalar? Scalar means no magnitude, no direction. No direction, this one and this one. This one got direction. This is a vector. So 2, 3, the answer is C. Wait, yeah, correct. 2, 3. Okay, velocity is a vector. Got is speed, then is a scalar. Okay, which of the following is derived quantity? Yeah, speed, because they got consist more than one SI unit. Okay, because meter second, right? They got 2 SI unit here, but temperature only Kelvin 1, length only meter 1, time only start 1 second. Okay, so the answer is A. Okay, you can see there are more than 2 units inside the formula of speed. Okay, 1 Newton meter is equals to, so we can just change kg ms negative 2, right? This is for Newton times with m. Okay, so this one I change it to the derived quantity. Okay, so kg ms negative 2, so kg m square s negative 2. So the answer is C. Okay, change the Newton to the base 1. Okay, the base. Alright, the next F. So this one is a volume. So we need more to multiply all of it. But you can see the unit is different. So you need to change it to meter. All of it have to change it to meter. Because the answer is in meter. Okay, but they have to put cube here. Maybe they forgot. Okay, this is the volume, right? Okay, so milli, if it's me, I just change it to prefix. Okay, but maybe some of you change millimeter to centimeter, then centimeter change to meter. It's up to you. Okay, but for me, you just remember the prefix millimeter is 10 power of negative 3, while centi is 10 power of negative 2. Be careful, okay? Remember in the trial exam, I think 50 ms, right? They put their time here for the impulsive force, right? So you need to see what is the physical quantity. If time means, of course, in a second. If they put m or let's say k in front of it, so mean there must be a prefix there, not 50 meter second. Okay, there's no unit meter second. If even like velocity also ms negative 1, not ms. So you have to see what is the physical quantity. If the time means only second, so let's say there's in front of it, you got m, you got k, you got micro, you have to change it first. Okay, so that's why you got wrong. Mostly you got most of you just divide by 5, I think, at that time. Okay, and then this one 0.3. Okay, so then you just multiply 20 times 20 exponent negative 3 times 12.5 exponent negative 2 times 0.3. So we got 7.45 times 10 power negative 4. Okay, you just use your calculator. So which of the following measuring instrument is the most accurate to measure the internal diameter? Okay, this is actually from Form 1 question. Okay, you know how to read the vernier calipers, right? The micrometer, screw gauge. Okay, whenever they say a diameter of water pipe, that one must use the vernier calipers. Okay, vernier calipers. Okay, if they mention about the diameter and the object for the diameter is quite big Okay, it's quite big, so you put it as the vernier calipers. But let's say they ask you the diameter of the wire, okay, of the wire that you use as a connecting wire. That one is very small, right? So you, of course, you're gonna use a ruler. Okay, it's not so accurate, right? So we have to change it. If you use a vernier calipers, it's still considered as a small, right? So we need to use a micrometer screw gauge. So if that means if the thickness of wire, very small thing, that one you use a micrometer screw gauge, because it has more it's more it more sensitive, okay, to the change uh, of the length of the diameter there. Okay, so if it's true, it's just like pipe, or maybe a diameter of shillings or the coins, right? And the one we can use the uh, vernier calipers. So a pipe is quite big, so you can use the vernier calipers. Micrometer screw gauge, thickness, usually thickness of the shilling, okay, of the coin, okay, or maybe thickness of the books, okay. You have to see what is the object there. If too small, then use micrometer screw gauge, okay. All right, the next part, increasing linearly, the answer is B, okay. And this is the last question, last page. Okay, and it says here, which quantity is manipulated? Manipulated always on the x-axis. Y-axis is the responding variable. Okay, so the answer is time. Okay, then the last questions, diagram 2 shows the graph represent the motion of the car. Equation of graph. Okay, so y mx plus c, y is v, m is this is 8, 10, this is 0, 2, right? So 10 minus 2, 8, 8, 8, 1, I think. Okay. So 1, x is s plus c, c is 2. So no, sorry, t. S is the unit. Take the physical quantity, not the unit. So the answer is A. Okay, the answer is A. Okay, if the gradient, let's check whether it's correct or not. No, the gradient is 5, right? Sorry, it's 1. Okay, I just calculate here. Okay, we just put the value. T is equals to 8, V is equals to 2. No, 10, right? Okay, and V is directly proportional. No, this is increasing linearly. Directly proportional, 0. Okay, okay, yes, the answer is A. Okay, so what can you see? So the pattern of the question for chapter 1. Scala, vector, graph, right? Unit, base quantity. Okay, that's the question. So why I did like this? So you can see the pattern for the question. Okay, in what in what topic? Okay, how do they ask you the question? Okay, so basically it's just like, if the thing is quite, just a repeated questions. Okay, just they change the number, okay, like that, or the sentence. Okay, the graph. Okay, and then the unit, okay, how to change, then derive base quantity, scalar, vector. Okay, so that's the type, okay, what they will ask in the exam. Okay, so is there any question you want to ask? No. If no, maybe we can go, like 2, 4, 5 questions, okay, for paper 2. Okay, I will go for paper 2. Paper 2, actually, for chapter 1, I'm quite worried also lah, because I see when you answer paper 1, right, most of you are weak in paper 1. Okay, that's why I want to do a revision for paper 1. Okay, for paper 2, okay, I think I already give it to you. Paper 2 is the most important. Why? Because in the question, in the paper, okay, you can see you learn force and motion in chapter 2 form 4, and also then there is a continuous, right? That chapter they have a continue. You have to continue to learn during form 5. They divide it into 2. So basically the force and motion is a very very a big chapter. Okay, a very big chapter for one. I mean, it cover a lot. So you can see even when I compile the question, they got 56 pages. Okay, but don't worry, we do one by one. Okay, wait. I try to open the paper two. You don't need to print, or if you want to answer, you just using your phone, and then you just write down your answer. Then when we discuss, they say it has an important notes, you just take a paper, okay, or just put it there. Oh my god, I'm not looking for this one. Paper one, exercise chapter two. Okay, I didn't give on your group. Okay, so we see the pattern, the question pattern for chapter two, form four. Then it says here, okay, an object will remain at rest or continue moving with uniform velocity unless it's acted upon by an external force to change its state of motion. Okay, this one is a inertia, right? Okay, so inertia. So let's say you are in the car. Okay, suddenly your father, push a brake there. Okay, then after that, what happened to your body? Your body will move forward, right? But then it will move backward. Okay, so means your body tends to move. Okay, tends to move to still moving. Okay, it still tend to still moving. Okay, to in front, even the car already stopped. Right, so that we call it as the inertia. Okay, but then in the answer given, there is no inertia there. Okay, but you have to know inertia also is known as the Newton first law. Okay, then the Newton's second law is the one that you learn that F is equals to ma. Okay, it's directly proportional to the change of the rate of change of momentum. Okay, so this is actually F is equals to ma. And the Newton's third law is the action and reaction. Okay, example, if I push a car, okay, if I push a car to the right, then there will be a frictional force acting on it going to the left. Okay, so they have an action and there will be a reaction. Same as you use a rocket. Okay, then if there will be a force, right, uh when the when the combustion occur, right, so the heat will come out downwards, right, downward, but then there is a force that acting upward, so that's why the rocket can move upward. So that one also is actually the Newton's third law. Okay, so this is actually action and reaction. Okay, the Newton's gravitational of law is the one that um this one. That one is chapter 3, not in this chapter. So in exam, you can see they already arranged the question according to the chapter. Okay, let's say 1 until 5, chapter 1, form 4. Okay, and then 6 until 8, okay, chapter 2, form 4. Okay, then 9 until 12, example, chapter 3, form 4. So they already arranged the question according to the chapter. So let's say just now let's say 1 2 sorry, the question number 1 and number 2 is actually chapter 1, right? Then of course 3 and 4 must be from chapter 2. Right, so for the Newton's third law is chapter 3. Okay, so means the answer cannot be D. So in the exam for physics, okay, for chemistry, bio, I'm not sure. Some of them say it's according to the, the level of the question. Making that one first one easy, and then the medium, then they become hard one at the back. But physics now we arrange it into the chapter. Okay, so then could be not, the answer cannot be D. Okay, so this one is A. Alright, which sport events uses the principle of conservation of momentum? Okay, what does the principle conservation of momentum say? The total momentum before collision is same as the total momentum before. Why I'm stressing out the word total? Okay, sometimes they don't put total there. They put the momentum before the collision is same as the momentum after the collision. That is wrong because we learn the formula for the elastic collision, right? It must be total because you add two momentum there. Okay, so you must have the word total there. Okay, this is elastic collision, right? If elastic M1 plus M2 times V. Okay, which part has the principal conservation of momentum? Okay, this is actually the impulsive force, right? This one, I think the answer is D. Because let's say you push, right? Okay, you push, I think the billet, right? They call it, okay? So then after that, the um, the ball will move to the front, okay? So the answer is D, okay? B is not a principal conservation of momentum. Okay, no, it's not. So the answer is D, donkey. And number 3. Okay, and I will discuss until trades number 6. Okay, then we will stop. Okay, number 3. What type of motion? Okay, so this one, what type of motion? You can see the distance is not changing during, let's say, t0 to 1. 0 to 1 second, they are moving 5 meter. Then after that, t2 to t3, 1 second. Okay, 1 second after that, still moving 5 meter. So this one is actually the uniform velocity because they move, okay, at the same rate of distance. Okay, but if come out for the acceleration, so this acceleration is zero acceleration because the uniform velocity zero acceleration. Okay, but let's say come out, this is 2 meter, okay, this is 4 meter, this is 6 meter. So this one is increasing velocity or uniform, the velocity is increasing or we uniformly, or we can say is accelerating or uniform acceleration. Okay, uniform acceleration or increasing velocity. Okay, uniform velocity means the velocity is same. Okay, yeah, if you divide 5 divide by 1, you got 5 meter per second. This one 5 divide by 1 because the time taken from here to here 1, right? 5 divide 1, you got 5 also. 5 divide by 1 also, you got 5 also. So means the velocity is constant. Okay, so uniform velocity. Okay, for number 5, okay, this is actually the calculation questions. Impulse. Okay, so impulse formula Ft is equals to mv minus mu. Okay, you can choose whether you want to use Ft of mv minus mu, but it have to depend on the question. What does the question give to you? That it doesn't mean you need to use both of it. Okay, so here they give you force, they give you time. So straight away use this one. Okay, this one then you need to have the initial velocity and the final velocity, which is not given by the questions. The question only give you the mass. Okay, so F and T means 30 times 0.5, you got 15 Newton second. Okay, number 6. Okay, it says a plasticine ball of 0.05 kg is thrown at the velocity of 10 meter per second and hits the wall. It sticks to the wall. If the impact time during collision is 0.2, what is the magnitude? So mean when they ask you about the magnitude, okay, we can just ignore the direction. Okay, so the plastic ball, this is the U, right? Okay, so then when it hits the wall, it sticks to the wall. So what is the V here? V is 0. Because it sticks to the wall means it's not moving anymore. So your V is 0. Okay, and your time is 0.2. So we can use that one. This is impulsive force, right? So mv minus mu divide by t. So what is your mass here? 0.05. What is your v here? Is 0. Okay. What is your m here? 0.05. What is your u here? Is 10. Then divide by 0.2. So negative 0.5, right? Negative 0.5 minus with 0.2 is the minus divide. So you got 2.5 Newton. Okay, actually it should be negative, but since they only want the magnitude, Okay, they only want the value, we can ignore the negative. Okay, because magnitude means you want the scalar only. Okay, because impulsive force is vector, so we can just use the 2.5 and the answer is B. Okay, so is there any question you want to ask before I stop? Okay, tomorrow also I will have a class, right, every night until you are starting your birthdays. After birthday, I will not disturb you lah. I mean at 20, I think. Okay, so tomorrow we continue to discussing this one. Okay, so thank you everyone. Right. So good luck for your lesson tomorrow. For those who have a lesson. Okay, so take care everyone. Bye.
Thank you, teacher.
Okay,
Thank you,
welcome.
Jill. Bye.
Welcome. Teacher, how we get this video recording? I will put in the YouTube. Oh yeah, because 5E also don't have in the okay, I don't have group in which class. Can you send me someone? Send to me someone? Okay. So then Jian, am I saying your name correctly, Jian? Okay. Then I will give you the link. Okay, because I will upload this one on my YouTube channel. Okay. All right. Just text me. You know my number, right? Okay. Take care, everyone. Bye.